So atmospheric pressure. Atmospheric pressure comes from the pressure of the atmosphere. Duh. Well, what is the atmosphere? The atmosphere is a gas, right? It's gas particles. Do you feel pressure from the air right now? I don't. We don't feel it because we're used to it. It's like if you start wearing a watch. At first you're like conscious of it, right? Because you're not used to having something on your wrist. But after a while you don't even notice it anymore because it's always there. We don't feel the pressure of the atmosphere because it's always there. The pressure of the atmosphere, though, can vary. And the variations in that pressure are what cause weather. Wind, what is wind? Wind is air blowing around. Why does it do that? Well, it has to do with high pressure and low pressure regions. Generally, if we have high atmospheric pressure, we have clear weather, and low pressure is generally unstable. We also see changes with altitude. If you drive up to Kings Canyon National Park, there's less air up there, right? You run around and you get out of breath more easily. Higher altitude, we have a decreasing amount of pressure. There's less gas particles per unit volume in the air up there. So the pressure of the atmosphere decreases as you go up in altitude. So we just said that the pressure is dependent on the number of gas particles. So if we look at these two, these look like mason jars. This one has fewer particles than this one does. So this one's going to have a lower pressure than this one, provided other things are equal. Why is this a lower pressure? These containers have the same surface area. They're the same size, same volume. Their surface area is the same. But there are fewer collisions because there's fewer particles, so the force is less, and that results in the pressure being lower. When you drive up to Grant Grove, Kings Canyon, your ears pop, don't they? And that's because your ears are dealing with the change in atmospheric pressure. So here's a diagram of an ear. You have a eustachian tube that connects the inside of your ear to your throat, and then you have the ear canal that comes in from the outside, and in between here is your eardrum. So here's your eardrum, and there is air on both sides of your eardrum. And when we stay in the same pressure, we have the pressure inside and pressure outside being the same, and everything's great. When you go up the mountain, the atmospheric pressure outside is lower, and the pressure inside your ear is the same as it was down here on the valley floor. And so your ear bulges out. That doesn't feel good. If you have an ear infection, it really, really doesn't feel good. That's what causes babies to scream on airplanes. And what happens? It builds up, and you're like, and then you hear this popping sound. The popping sound is your eustachian tube opening up and letting some of that air pressure out and reestablishing the same pressure on each side. The reverse process happens when you come down. Now you have less pressure on the inside of your ear, and your eardrum is bulging the other way. And then you'll get popping again as air comes into your ear. How do we measure the pressure of air? Well, we can use a barometer. This is an illustration of a Mercury Barometer. We have more fancy designs now. Oh, we also have an issue. Hang on. I just had to move my barometer over so we could see the words. This is a rather crude Mercury Barometer, but it's the kind that was similar to the original one. A guy named Torricelli, I really wonder how people come up with these ideas. Anyway, he took a glass tube, long glass tube, giant test tube, full of liquid mercury and turned it over in a dish of mercury. Now, if you've played with water in the kitchen sink or the bathtub, you know that you can take a drinking cup under the water and pull it up upside down, and the water stays in the cup, right? And as a child, you're like, wow, that's so cool. And you lift it up and all the water comes out. And you're like, what on earth is going on here? But this is really fun. I'm going to do it over and over and over again. Happens the same every time. Well, maybe this guy, just expanded and he was, branching out, and instead of liquid water, he's using liquid metal, which is mercury. Mercury is a lot more dense than water is. And what he found was that no matter what he did, what size tube or anything, the height of the mercury column was always pretty much the same. Like, very interesting. Not all the mercury would stay in the tube. Some of it would come out, and what was up here was a vacuum. But the height of the column of mercury was about 760 millimeters tall. And that is one way to measure the atmospheric pressure. How is that mercury staying up in there? Well, the atmosphere is pressing down on the mercury in this dish, and the pressure of the atmosphere is able to support a column of mercury that is 760 millimeters tall. When the atmospheric pressure is lower, then more mercury comes out and the column is lower in height. When the atmospheric pressure increases, it presses down and is able to support more mercury here, and the column grows. And what he actually did is he carried this thing up a mountain. And the higher he went up the mountain, the shorter the column of mercury became. And then when he walked back down the mountain, the column of mercury grew back up to the same size. And so the height of the column of mercury is directly related to the pressure of the atmosphere. And this was like a super cool thing he figured out. And so they measured pressure in this really weird looking unit, millimeters of mercury. Now hopefully, since I explained the Mercury Barometer to you, you can see that, oh yeah, well that's a reasonable thing. The height in millimeters of a column of mercury. If you don't know about the Mercury Barometer, you're like, how is a length of an element related to pressure, right? Well, it's only for the barometer. But higher pressure, higher column, and millimeter of mercury, we still use this. I think we're trying to get away from it. So they created a unit in honor of Torricelli, and so it's called the torr. 1 torr is 1 millimeter of mercury. So those two units mean exactly the same thing. They're just different names for the same thing. So 760 millimeters is what the height of the mercury will be at sea level. There are many units of pressure. You're probably familiar with PSI. If you've ever pumped up a bicycle tire or a car tire, PSI stands for pounds per square inch. This is an English unit. That relates to force per unit area. Pound is a unit of force, square inch is an area. So PSI, 1 atmosphere is, or the pressure of the atmosphere is 14.7 pounds per square inch. Here's the torr. 760 torr is the same as 760 millimeters of mercury. All of these numbers, all of these units are equal to 1 atmosphere. This is an exact relationship. 760 torr. It looks like it has 2 significant figures, doesn't it? But that 760 is an exact number. So 1 atmosphere equals 760 torr, that's exact. We could also measure the height of that column of mercury in inches, and that's what the meteorologists do. And so they may say, oh, the barometric pressure is 30.1. What they may or may not say inches of mercury, but that's what they mean. Pascal is another unit. We don't generally use that in chemistry, although we sometimes make you do conversions with it. Pascal is a Newton per square meter. 101,325 pascals is equal to 760 torr, or 1 atmosphere. Why do we have all these different pressure units? People in different fields use different units for their pressure. We use a unit that is similar in size to the amount of pressure that we're measuring. So the ones we use most often in chemistry are torrs and atmospheres. Now, converting pressure units, because of how that table is set up, and this is how temperature conversions are sometimes given. Because of how these are set up, you can convert pressure units in one step. Because all of these are equal to 1 atmosphere. Because they're all equal to 1 atmosphere, that also means they are all equal to each other. Okay? The one I want you to memorize is this top one. This guy. An atmosphere is 760 torr, which is 760 millimeters of mercury. And you ignore those numbers in terms of significant figures because they're exact. These other guys, if they're down, these guys down here, if you needed those on an exam, I'd give them to you. I don't think you need to memorize those. And so doing these conversions is just dimensional analysis. So let's convert 35 psi to torr. So we just start out with 35 psi, and we're just going to have one conversion factor. What we're going to goes on top. What we're getting rid of goes on bottom. Units cancel out. The numbers, we go to this table. In front of torr is 760. In front of psi is 14.7. 760 torr equals 1 atmosphere, and 1 atmosphere equals 14.7 psi, so 760 torr is equal to 14.7 psi. Oh, I never got my calculator out. So 35 times 760 divided by 14.7. How many significant figures should this answer have? 2, because of the 35. Okay, so the calculator is showing me 1809.5 blah, blah, blah. So I need to round it to the second significant figure. That is in the thousands place. Be careful. Okay? If you're rounding to a decimal place above 1, the ones place, so tens place, that's not the thousands place, that's hundreds. Like I said, adult brains today. Anyway, if you're rounding to ones, you're okay, but tens, hundreds, thousands, be careful. Put it in scientific notation first and then round it. So this would be 1.8095 times 10 to the what? 3. And the unit is torr. Now I can round it without worrying about changing the value. This is 1.8 times 10 to the third torr. The common error I see is students will tell me that's 18 torr. Okay? Because they turned off their common sense. I saw a great thing on Facebook. Common sense is so rare that it should be considered a superpower, right? Sure. So all of you need to be super, and someone's actually wearing a Superman t-shirt, so that's even more awesome. So we're all going to be supermen, superwomen, and use our super common sense power, right? We can't round 1809 to 18. You're gonna have some bad luck and some business deals if you're going to go with that. Okay, inches. Inches of mercury, 30.41 inches of mercury to atmospheres. So we put atmospheres on top. We put inches of mercury on the bottom. We look in the table. It says 29.92 and 1. So 30.41 divided by 29.92. And this comes out, how many sig figs should this one have? 4. 1.016 ATM. ATM is atmospheres. It's not an automatic teller machine. Any questions? This should be pretty straightforward, easy. Oh, another problem with the PowerPoint. That's better. Okay, a manometer. Barometer is used to measure atmospheric pressure, but it doesn't work to measure pressure in a container. For that we use a manometer, which uses the same idea. So here we have a tube that's shaped like a U. These are always called U-tubes. And now that just sounds funny because that's a channel of videos on it. But anyway, there's our U-shaped tube. There's our U-tube. And this is going to have some mercury in it. One side is going to be attached to the container that we want to measure the pressure in. The other side is open to the atmosphere. And so what we see is, we'll see a difference in the heights of these columns of mercury if there's a difference in pressure. So what this measures is not the pressure directly, it measures the difference in the pressure inside the container and outside the container. And again, we can measure this by the height. If this one was also open to the atmosphere, this would go down, this would go up, and they would end up being the same. Okay? And of course, there are many other pressure gauges and things that we have come up with, but those are the simple ones that are easy to understand.